Hello, ladies and gentlemen. This year I'm, for the first time, not talking about energy, but about the environment. So this work has to do with my doctoral thesis. The motivation to start with this is that there is an increasing environmental concern. So we are not just worried about the climate change, but also about the nitrogen cycle or about biodiversity loss. And it also has economical aspects, like we are continuously, because of the growth of the population and the increase of the life standards, we are increasing energy consumption, water, materials, and metals all over the world. So somewhere we will have some problems, cities have been pointed as one of the highest environmental problems, and in a report published in 2008, it's been said that they are responsible for 70% of the CO2 emissions. So the lift sector belongs to this building industry, and to cities there are a lot of elevators installed in cities, and they can also contribute to reduce the environmental impacts by selecting the best lift for each application. Now we are talking about the best environmental lift, or the one which is harming the environment less. But the question is, how can we know which the best lift is? So by now we have just been concerned about energy consumption, but there are other aspects. There are some building classification systems which are trying to foster the most environmental options, construction options, and some regulations. But as I said before, we are by now just mainly concentrated on energy consumption. So the best tool to know which the best lift for a certain application is LCA, life cycle analysis. I don't know whether you have heard about this. It's a standardized methodology which is applied all over the world, and it consists on defining our product system, which in this case is the lift and everything related to the lift for fulfilling its function. And so we measure all the inputs in materials, resources, and energy that we introduce into the system, and all the outputs. So this file is wrong. The outputs that we get or we send to the environment. So these are emissions to the water, to the soil, or to the air. Why we are doing this? Because in life cycle assessment, we analyze the full life cycle of the product, and the purpose is to avoid that modifying one of these life cycle phases, we shift the environmental impacts to another phase. For example, if we just concentrate on the usage phase, if we just look at energy consumption during usage, maybe we are putting a lot of new materials which are worsening the environment. So it's necessary to take a global approach, a holistic approach. So when I started my research, the construction sector was already demanding environmental data, and mostly big manufacturers were providing them. And I read very often that energy consumption was the most important phase of the lift life cycle. And this was approximately 70% of the total environmental impacts. But if you know about life cycle assessment and environment, you start to question, how did they measure it? So I don't know which is the functional unit they have considered for the assessment, which is the life of the lift that they have considered, which is the method they used for calculate the energy consumption, what environmental categories were considered, just CO2 emissions or also materials consumption, or what have they assessed. So there was no information about this. So and if we just look at the usage phase, which was supposed to be 70% of the lift environmental impact, at that time there was no common methodology. Since 2009, VDI has been the methodology used for classification, but if you try to apply it for a life cycle assessment, you have many difficulties, as we will see later on. The most accurate ones use simulation, and this makes it complicated for other people to estimate the life cycle impact of a lift. And they did not consider measurements. And they did not consider idle status, for example, which is has a very important impact in the usage of the lift. So if you want to define a methodology, what was needed, all experts say the first thing is that you start with a simplified analysis, in this case of a lift, choosing reference lift, then you check the results of your environmental assessment, and you carry out a sensitivity analysis to check what is the influence of everything that you have considered. You vary them and you check what is the effect in the environmental results. Knowing this, you can complete the data gaps and suggest a common methodology. So this is exactly what I made. And these are the key questions. I want to make you aware of the complication of this LCA analysis. First of all, you have to define, we talk about the inputs and outputs of our system, but what is the lift system? So the lift sector is very complicated. There is a very long and complicated supply chain, and there are many companies taking part in the different phases. So starting from component suppliers, transport or logistic companies, assembly companies. Sometimes the maintenance is not carried by the same company that sold the lift, modernizations, there are some repairs, etc. And we don't know yet what is the end-of-life treatment of lifts, because there is no much information about that. These are, considering the life cycle analysis methodology, which is standardized, as I said, these are the key questions. So first of all, you have to define the goal and scope. So how you are doing it, why you are doing it, what are your goals, which is your target group, whether you want your results to be compared or not, what is your product. And the second step is you have to inventory or to balance all your inputs and outputs. And then the data quality plays a very important role. When you have all your data, you have to assess the impact, and then you have to define the impact categories that you want to consider, for example, global warming or ozone depletion. And concerning the interpretation, it's very important that you check your system boundaries. I will explain later on what it is, and the assumptions you made on the assessment. So the goal of scope was to develop a common public methodology, because, as I said before, every lift manufacturer was doing it differently and was not publishing how they were doing it. So it had to be public and common for all of them. But the most important for all the companies in the lift sector, because we don't want this to be used as a marketing tool or to be used to throw some small companies out of the business. The goals of the methodology is that it has to be very simplified, mainly for the data collection, because this is the biggest question in life cycle analysis. You can spend years trying to collect all possible data you need for the assessment. Another goal is that it is credible, because there are a lot of environmental communications which do not fulfill their purpose, because people don't believe that something is really greener than before. And the target group have to be product developers, company strategic planning, purchasing, marketing, etc. And as I said before, we want to compare results to know what the best lift is. The definition of the product, we don't need to invite it, because it's in the CIPSI guide and it's very clear. And the functional unit is the most important in life cycle assessment, because it's you have to consider a product which is fulfilling a function, and in the case of the lift, it is to transport people for a certain distance. So this functional unit has to be people transported on a relative distance. To know this, during the full life of the full useful life of the lift, you need to know the number of passengers and the load transported during the life of the lift. And this is very important, that's why I have highlighted it in red, because, for example, VDI didn't provide this data. So everyone, still now, are using VDI to carry out life cycle assessments, but they don't know how many, what is the average load transported, or what are the number of starts, or some parameters which are important to divide all the environmental impacts by this functional unit. So this is one question why ISO 25 blah 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 is going to replace VDI. And it's not me who's saying that, it's all the sector, all experts who agree that it is better so. So for calculation this functional unit, as I said, you need to know the average number of passengers per trip, the average number of floors traveled, or average distance. These are two of the parameters. If you know the new ISO, they are given there. And this is given for different usage categories according to the number of daily starts. This was another problem of VDI, because the usage categories were based on general descriptions of buildings, and not on a parameter which was unique, like a number of starts. Next step is you have to split the lift into its components, and you have to do it in the best or most structured way, because otherwise you can double count some components. If you allocate them to the wrong structure, you can count them twice and then increase your environmental impacts because of the long and complicated supply chain. Next, you have to check all the analysis and processes involved in the life cycle, and all inputs and outputs of each of these processes. I'm not going deeply in this because you have all the information in the paper and in many other places. So I just want to make you aware of the complication of the methodology and how we are solving it in the sector. I said before, system boundaries are very important because we cannot, so if we think we are starting from the extraction of raw materials like zinc or copper, and we are finishing treating the lift at the end of its life, if we want to check such a huge product with so many components, it can be endless. So we have to make simplifications and forget about some processes. And this is very important, This is very important, and this has to be declared when you give the results of a life cycle analysis. Finally, it is important to know who has the responsibility of reporting, mainly because of the quality of reporting. Is it my supplier? Is it me? Because it's me who's selling the lift to my customer. This is very important. For the use phase, and this is in fact the reason why I started to work in the ISO committee, because I started with the life cycle analysis. I saw there was no methodology. I started to investigate on how lifts were behaving, what were the important parameters. I was lucky that I could join this very, very good group of experts, and this is what we developed, the ISO, where we gave all these tables I mentioned before. So now we have already solved this usage phase problem. For the data, I'm not going deeply. And the other important point is, what am I measuring? I am measuring global warming, or am I measuring just energy consumption, as the former speaker said, or am I measuring rare materials? For example, if I'm using gearless machines, we have different impact categories which can be divided in midpoint or endpoint. Endpoints contain not objectical weighting factors, and therefore they are not liked by scientists, but for comparing products, they are much better. So, this is the theory. So this is what a LCA method or an LCA assessment has to take into account. And this is the results of the reference studies I conducted to check what are the important things or important aspects in lifts. So this is a very important result, because I said before, in the lift industry, everyone said the usage phase is the most important and it's 70% of the impact, but this is not true. Because if we look at the different usage categories, we see it's only in these two cases where, or this, if we consider VDE, where the usage phase is more important than the others. And this is very important, for example, for the hydraulic industry, because these kind of lifts were out of the market for energy reasons, but they are in other phases of their life cycle much better, regarding maintenance, regarding installation, and so on. So it's important to check or to consider that it is not always the most relevant phase. And what I show here is the estimation method is very important. I mentioned before that VDI was not right for this assessment. And if you check here, you have a big deviation. Although I have to say, I explained it in the paper, I didn't have idle data from this lift, because this was from all measurements. So I have just considered that idle consumption is the same as standby. If I did have the idle data, this would be higher in all cases. But in any case, you see there is a big difference. So the right methodology is also important. And in the paper, I explain why I get these differences, and it has to do with these traveling and standing times. Because VDI is based on estimations, and after many simulations that we use for developing ISO, we see that we are actually running much less time than we thought. And also running time, or the time in idle or between stops, is standing, is not running, and maybe VDI was considering that as running, but then we are increasing the energy consumption. Another finding is that some components, depending on the environmental category, this is this aggregated indicator, this is global warming and soil depletion and so on, depending on the category, it is a different component which has the highest impact. For example, electronics have a very high impact. So sometimes when we try to reduce energy consumption putting a lot of electronics, we are not doing it right for the environment. Mainly if we have a very low usage intensity. Concerning the lift composition, this is the distribution of weight by components, and this is the distribution by type of material. So the lift is mainly made of ferrous metals, which have the advantage that they are theoretically recyclable. But to recycle these materials, we have to be able to dismantle them. So it's very important in the future that the lift industry considers how to make lifts dismantleable. And this is to show the difference, is similar to the table before, the difference importance that each phase of the life cycle can have depending on the category considered. If we look at global warming potential, this is just for the materials phase, is 36% of the environmental impact. So in this case, we would say usage is more important. But if we look at eutrophication potential, which is also an environmental problem, it's 63%. So that's one of the reasons why these aggregated methods give us a better view. If we take this aggregated indicator, we have that materials is exactly 50% of the impact in this specific case. And as I said before, after conducting the first proposing methodology, then conducting the assessment, then you have to check the sensitivity. And these results are sensitivity to the materials considered. It's not the same if I consider steel, which has a very high recyclability content, or if I'm approximating plastics because I'm not sure what the real plastic is and so on. The maintenance operations, because this determines the amount of spare parts that I will use during the useful life. In the use phase, we've talked about that many years, so 2-3 years here already. So a number of possible standard trips and time in idle and standby. Counter-waving was mentioned before by the former speaker. Energy consumption in standby, end-of-life treatment considered, because if I do recycle some parts, or if I do reuse some parts, I can reduce the material phase impact very much. And this is also very important. Eco-indicators consider databases. There are public databases which are often used by LCA practitioners, but they are not the same good. So some of them are very good, others are not. And the energy mix. So some countries have renewable energies, and they can reduce the environmental impact of the usage phase very drastically. Energy consumption, you already know. And all this is needed because when the lift industry want to show, mainly to their customers, to the building industry, that they are committed with the environment. So it's important to define how to communicate these environmental results. There are several options. I suppose you are familiar with these kind of labels. They are also standardized. There are different types. 1, 2, 3. Officially, there are 3 types. But some people invent new labels which do not fit any of these categories, thus reducing their credibility. And in the case of business-to-business communication, this is the most, the best one. I will explain it later on. And in the future, you will see this sign in some of the environmental declarations of the lift industry. Why this type 3? Because it's a company declaration, because it's for business-to-business communication, because there is a third-party verification, because it's based on LCA, as I say here. The transparency is very high. You give all the data of your analysis, and the credibility is very high. Type 2 are easier to produce, but no one believes that the products are really greener. So this is the reason why the sector has decided to use environmental type 3 declarations. And as I said, there is already an initiative going on. This is the sign I mentioned before. This is ruled by Environment. It's an organization, everything is standardized. It's an organization which has defined a procedure to conduct life cycle assessments. And the leaf sector is defining what are the rules I mentioned before. What shall be the system boundaries, what shall be the indicators considered, what shall be the materials, the databases, and so on. All this to reduce all these uncertainties in the declaration of the results. And if you want to make your comments, the first draft will be ready by March next year, and there will be a consultation process. Currently, this is led by Ella. So Ella is working on that. The University of Berlin is the moderator. And as I say, you can go into this web page and have a look at what there is. Yeah, so this is the summary. And finally, if you want more information, this is everything is explained more deeply, because I suppose this topic is quite new for you. And I just wanted to say here, there is still a lot of work to do. So improvement of the data given in the product category rules for the assessment, obtaining statistical information from the sector, consider ways to promote some more sustainability development in the sector, standardization of LCA, traffic definitions, that's already going on, improvement of ISO even, because it was a first draft or a first release, but it will have to be improved, development of tools for data collection, and so on. So there is still a lot of work to be done. Thanks for your attention.
Thank you.